this stuff with snow research, so I have a heart for this stuff, but today is not about interesting things that I find. It's about you guys learning the things that are important to stay alive. So I'll be talking about SnowPack. So you have the SnowPack. It's some layered thing. Snow doesn't come as one continuous thing and it's all the same. Snow comes in a storm and then stuff happens. And then more snow comes and that snow can be different and then more stuff happens. So this is an example snow pit taken a few years ago. So as you can see, there's some popsicle sticks and those indicate different layers. And you can see someone tried to put their finger in, and as it got less cohesive, it got easier to put your finger in. So that's to say, there's a lot of stuff happening in the snowpack. There's even a pretty peculiar dust layer here, which seems to be happening more in Colorado. But there's different types of layers, and each layer is created by some physical process. And I want to convey how these things actually happen. So there's precipitation, which is pretty easy to understand, faceting, rounding, melt freeze, and then there's other stuff like there are ice villages in the snow, ice happening in the snow, and then odd stuff. So before that, a common question I get is why do I care about what is happening in the snowpack? And it's common in our everyday life. We care about the science of things that happens every day. But the difference is that we've built up our intuition through our lives to know, well, if we go too fast and there's water, we'll hydroplane because there's no friction. But you don't think about what's the equation for friction here and am I going to slide? That's not really how it works. So my goal is to try and convey the basic science at a basic enough level that you get an intuitive understanding of what's happening. So there's two questions I would really like to answer, which is, for each of the things that I mentioned before, what processes are making the snowpack change over time? And the big one in the snowpack, for the things that we care about, especially in Colorado, is something that you guys experience every single day probably, especially now that we've turned on our heaters. So you turn on your heater and your house is cold, your heater makes warm air, and warm air goes to cold air. The same thing is happening in the snowpack, and it's one of the biggest things that drives change in our snowpack. Or you hop in the shower, you close the door, it gets all misty, you open the door, and then the misty air goes out. It's going from hot to cold. So that's one of the big things that's happening in the snowpack. And then we would also like to understand, how is the snowpack structure related to stability? So the reason why I really want to get at this question is that I was once in an Avalanche course learning, and we were presenting some results to this patrol director, and they weren't experts. All they wanted to know is, and what the beep do you want me to do about it? So all this science stuff is great, but we need some actionable thing to do. That's why you're here. So I'll be talking about different snow mechanical properties. Snow can act in different ways. And then there's also some thermodynamics at work to make snow change in the snowpack. And all of this is driven by heat flow. Then, kind of implicitly, I'll also be talking about when you look at the snowpack, it's not all the same. There's different layers, and each one does something different, and not necessarily good or bad, or makes it more stable or less stable. They all combine to do something good for us or bad for us. So this is an example of surface horror. So if you've woken up in your tent at night, in the morning after a cold night, and there's water everywhere, that is water condensing because air can't hold the water. Well, surface horror is the winter version of that. So if you've skied in the resort in the morning and it's clear, and you look down and it's really sparkly, that's surface soil. You've seen that. Now the problem isn't when it's on the surface, it's when it's buried. This is a crystal called depth ore, and as we speak, this is what's forming at the bottom of the Colorado snowpack. This is one of the big reasons why Colorado is one of the worst places for avalanches. And then there's other things like graupel, but we're mainly concerned with these sort of things. So to try and fix these ideas in your head, we're going to look at a snow crystal hierarchy. There's different types, and there's a whole bunch of subcategories. But they're precipitation particles. Generally, anything that comes from the sky is a precipitation particle. And for our purposes, what we really care about is once these things are in the snowpack, then what happens to them. Sometimes it matters, like graupel does some interesting things, but mostly we're going to talk about once it's in the snowpack. Then there are persistent grain types. So these things are persistent because they last a long time. They last pretty much the entire season. And that's why they're so problematic. So one of these is facets. So like I mentioned, Colorado is really bad for avalanches. These are the guys that are the culprits for that problem. And surface ore is also another crystal that is very dangerous and also stays around for a long time, unfortunately. Then there's melt freeze, which happens in the spring, which is self-explanatory. It melts and then it freezes, and then it does it again, making great corn. And there's something called grounds, which I'll get to later. But first, there's some things about the snowpack that are useful to know before understanding how those things come to be. So first, snow is mostly air. So we ski, 5% powder here, 7%, at most 10%, but still, the snowpack is mostly air. And also, that air is at 100% relative humidity. So this is a scan of the snowpack. They took the snowpack in the lab, and then they took scans of it, and then this is what it looks like. There's more complex things, but that's basically what you need to know. But because there's 100% relative humidity in the snowpack, and there's mostly air, when air flows through the snowpack, it does things. It bumps into people, maybe breaks connections, or does other interesting things. But there's a lot of water in there. Snowpack also has a density and a hardness, and it's important to know that these two things are different. So, for example, we've mentioned a lot of times, and we'll explain why these are a problem, that facets are a problem in Colorado. But facets are the same density as wind-packed snow or maybe settled snow. But the reason we care is that they have different hardnesses. So we're not going to measure density in the field. I do not for science, but that's not what we want to do. We want to measure hardness, which measures how cohesive is the snow. Because if you have something really cohesive, really not cohesive, that makes our avalanches. So this is an example of what you might do in the field where you get hardnesses, where you poke the snowpack with your finger, your forefingers, your fist, and that really gets at something that's less cohesive than your fist. If it's very cohesive, you might try to press your finger in and it doesn't go in, but this is an example of something you might do in the field. Snow is also both elastic and brittle, and as Cindy mentioned, the thing that we care about here is how fast are we straining the snowpack. So, for example, a storm that's straining the snowpack at a very high rate with wind and new snow, that's going to make the snow less wanting to take on that change without complaining and doing bad things for us. So that's an important snow problem. So there are lots of things happening in the snowpack. In the snowpack, solids are going from liquid and back to solid. This happens in the springtime. Every spring we have melt freeze. Have you and Roger had a great photo of gas and liquid with the lift having a whole bunch of brine? That's condensation. And in the snowpack, the thing that we care about to figure out what it's actually doing is this, gas and solid. So always in the snowpack, things are going from solid to gas to solid. And then the process processes that make things, good or bad for us are, well, where is that going? So there are two general snowpacks that we kind of divide up when we talk about snow metamorphism. There's the dry snowpack, that's our winter snowpack. That's a snowpack that we'll have now until like March. And then after that, we have the wet snowpack, when there's water throughout the whole snowpack and really it's just a mess of slush. And in the dry snowpack, faceting and rounding are the two processes that we care the most about in order to determine the stability or instability of the snowpack. So, to explain how faceting happens and make an analogy. So, who's played Jenga? Right? Well, if you haven't played Jenga, this is how you play. You keep on removing blocks and you put them on top. Sometimes the fun variant is you drink beforehand, or the loser drinks or something like that. And you try to not be the guy that takes the block out and then have the thing fall over. So the snowpack, when it's faceting, it's like Jenga. So if I have heat flow, so let's say this is the ground. The ground is at 0 degrees. And how cold is it going to be on Wednesday? No? Well, low of 1, so cold. So the air is cold. And then we have some snow. So which direction does heat want to flow? Up. So Jenga in the snowpack is like, I'm going to now take a block. And then take a block here. And then take here. What happens when I keep on doing that? Is it getting stronger or weaker? It's getting weaker until it gets to here. And then eventually it's weak enough that it can fail. So this is exactly what's happening in the snowpack. But humans aren't removing the snow crystals and moving the snow, something else is. So, like the example I just gave, the ground is at 0. Very cold at the top of the snowpack, so heat wants to flow. This is called a temperature gradient, because you have a change distance. So, usually what we care about is when we have, in Jenga, like our critical moment is that we remove 1 block per turn. In the snow, we care about when this difference in temperature is about 1 degree per 10 centimeters. That's when there's enough heat and water vapor flowing that it starts doing stuff that's not good for us. So this can also happen in other contexts. So for example, when you get an inverted snowpack, so you get cold storm, and then you get warm storm on top of that, or in the same storm. There's a heat difference there. There's faceting that also happens there. So it doesn't have to be at the bottom of the snowpack. So this is an example of faceting. So water vapor is going up, removing from the top, and building up the bottom. I'll play that again. From a crystal somewhere down here, evaporate the top, or sublimate the top, sorry. You get something like that, which in real life, that process looks like this. So crystal keeps on growing, growing, or here it grows like this. And these are easy to tell because they look very plate-like. Shying away from its neighbor. Breaking this bond here. So that's the process of faceting. And the way that they now, what I want to do is show you an example of if you were to look at a snowpack, how can we find out where it's faceting? Because where it's faceting is where I have a problem. So let's say you have a snowpack. So I dig a snow pit, and I say, well, I'm going to just tell you this all here is new snow. This is round, so it's just dense snow. We'll get to rounds in a moment. And these are facets, and this turns out to be an ice floe. So ice layers are at what temperature? 0. So what happens if this is cold? This is at 0. There's a temperature gradient, so there's faceting here. So this is a snowpack that's ripe for faceting. So now what I want to show you is, this is something you might see later in the field, but this is the snowpack drawn. And what I want to highlight here is that this is the depth, so going deeper, 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 and this is the temperature going higher, higher, lower, 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 lower. And this is mapping those on. So now, if I told you that this line, if anything above this line is a less than 1 degree temperature gradient, what do you think is happening here? Anything greater. So this is, there's no faceting happening here. Because if there were faceting, it needs to be steeper. It needs to be that way. So there's no faceting there. If I put my thermometer there, and voila, there's rounds. So physics works. If I look here though, this is sort of mixed. This is, the temperature line goes above and below. So this is, faceting a little bit. And as it turns out, it's not super faceted, but it is faceted. And then if I look right by the ice layer, this is definitely faceted. So when we go out in the field, what we'll look at is, we'll look at the ground, scoop some, and we'll see that it's depth first, not very good. So this is what the crystal looks like. So it's easy to tell because there's these characteristic little plate-like things. And then this is a zoomed out photo of how it might look. This is an example of new snow becoming a facet. And the biggest takeaway here is
just shrunk, just shrunk, just shrunk, just shrunk, just.
So the snow is really just junk. It's not cohesive at all. So if you put a big snowpack on top of it, do you think it's structurally strong? No, it wants to fail. So that's why facets are such a problem for us, because in Colorado the ground is 0, we get some snow, not very much snow, and then it gets very cold. And then we know when there's warm to cold, what happens? We get faceting, and then new snow comes on top of that, and that facet is weak or strong? Weak. So that's why this is a problem.
Just shrunk.
The last thing I wanted to say is that these called are persistent grain types for a reason. It's because they stay around the season for a long time. But why? They stay around for a long time because in order to form, in order to sublimate and then deposit, it needs to go from solid to gas to solid to form, and then do that again to break down. So all that energy that was formed by heat flowing, that needs to be undone in order for it to go away. And that takes a long time to do. So that's fascinating. And you can find facets throughout the snowpack, but most of the time we'll find them at the base of the snowpack. They're called depth hoar or basal facets. Spelled H-O-A. So the natural question is, what happens when there's no temperature gradient, or when it's so low that you don't worry? So what happens is a process called rounding and sintering. So rounding is individual snow crystals become from pointy to round, and sintering is those crystals bond to each other. And these are separate but related. So now, let's imagine I'm that snow crystal. My points at the tips are hot spots, and at the center are cold spots. So what happens when we have hot to cold? Hot goes to cold, so over time I'm going to be like this, and then I'm going to come in and become more like this, and then come in further, and then come in further, and then I'll become around. While I do that, while I do this, I'm going to be looking at my friend and be like, hey, do you want to hook up? Let's hook up. So not only am I becoming a smaller crystal packed into a smaller amount of space, but I'm also hooking up with my buddies and becoming more cohesive. So that's why when grounding happens, you dig a snow pit, maybe the bottom's facets, but the center is really hard snow over time. That's this process happening. So this is an example of a scan taken. This is hard to see, but it's really rigid. That's all you need to see. This is a T0, and this is 90 days later. It takes 90 days to look super rounded. 90 days for it to do something like this, and go to this, and form necks like these. So rounding is a very slow process, but it's what gives us slabs. And I said that these crystals weren't necessarily good or bad because if we have an all facet snowpack, no big deal. Unfortunately, we have a facet snowpack, and then these things become cohesive, and then we have a slab, and then we have a slab over a week. So this is a picture of crystals. So some of them are faceted, but they are becoming rounds. So this is a super common thing to see in the snowpack, that you'll see something that sort of looks like facets, sort of looks like rounds, but you're not sure. So this is a video of that. This is rounding happening. And with rounding and centering, there's a related thing that happens, and that's settlement. So gravity compacting down the snowpack, and you can sometimes see it like this happen. And there's other things happening in the snowpack, but we'll talk more about that. So that's rounds and how they round and center. So what is the critical point for having rounding happening? Less than 1 degree C, and rounding is when crystals do what? Shrink, and centering is neck. Cool. Well, you're acing. Just be done. No, we still got a couple more. We have surface horror and mouthpiece. This is Ron Johnson of the Gallatin National Forest. This is an excerpt of a video from A Dozen More Turns. It is a fantastic video that you should watch. Tragic accident. And this is Ron Johnson talking about surface horror.
Surface ore, if the name implies, forms on the snow surface. It forms when there's cold, clear, calm, and it's basically frozen glue. Oftentimes, they manifest themselves as big, feathery bristles and really sparkly. The reason there's such a problem as far as building snowpack, certainly because of when it's on the surface, it's one of the layers. It's one of the layers that is the most deadly.
So, this hits on a lot of the things we talked about before. It also mentions one kind of last thing in passing that I'll emphasize again. Surface horror is extremely dangerous. It is the most dangerous of all snow crystals. It can break at very unexpectedly low degrees. But I'll leave that to next week when I do stability evaluations. But I'll just hammer that point again. So, how does surface horror form? So we know it's the same process that happens when we get dew in the morning, but what is that process? So, let's imagine we have a storm that rolls in. Storms are generally very humid. Now, the day after the storm or the night after the storm, what happens? Temperature goes, drops. It's clear. So, what happens is that the air no longer is warm enough to hold all the water that's left over from the storm. So that has to go somewhere. And when it's near the surface of the snowpack, it says, well, hey, you want some moisture? And it drops. So that's how surface water forms. So this plot shows how much water is in the air versus temperature. So say we were at 30 degrees during the storm, and then after the storm it dropped to maybe 20. This is or even 15. It can hold hold only half the water that it used to be able to hold. It's to get rid of water. So then you get stuff like this that forms on the snow. Big, feathery crystals. They can be super large, they're super pretty, super deadly. The problem is when they get buried. So when they're buried is when we get the problem. So this is a slab that's failed, and they're like champagne glasses, not strong at all. And they're also very lubricant, very smooth surfaces. So that's surface work. So now we've covered persistent grain types, facet, surface ore, and grounds. So the last two are the easy ones. So melt freeze happens in the springtime, happens other times, but mostly in the springtime, and it's pretty obvious. It gets warm in the day, melts, there's free water in the snowpack, and then it freezes, and it does that over and over and over again, and hopefully makes corn, sometimes not, sometimes big death balls. So that is melt freeze metamorphism. You can get cool stuff like huge pinwheels, and then we'll talk more about the interesting things that happen when there's lots of water in the snow. And the last thing is precipitation particles. This is snow making in a lab. So anyway, it's a beautiful process. There's a longer version of this video elsewhere, but the main things that we need to know, there's many types of precipitation particles, but in my experience and practice, usually you don't care about whether it's dendrite, column, or whatever. Usually you care about like how warm is it, how much snow am I getting, at what rate am I getting snow. Those are the things you really care about. The one exception that I'll highlight is grapple, because if grapple's a weak layer, it acts in very weird ways because it's ball bearings. One stuck a snow pit, and then they started pouring out, which is not good. And then we got off the slope quickly. So in practice, grapple is the layer that I would treat differently. Also because when things are precipitation particles, they generally haven't been buried too deep. So that's precipitation particles. So at this point, we've talked about most of the things that happen in the snowpack, especially the ones that we care about. So in the dry snowpack, what's faceting? Faceting is the Jenga process. New name for it. So what happens when faceting happens? Not necessarily, but it's becoming less cohesive. That's the big takeaway. That's not universally true. For example, if you've skied recycled powder, it is certainly losing some density there, but the reason why it's so nice to ski is because it's become less cohesive. So if you don't know the term recycled powder, storm comes in, it's wet, it's not great, 2 days later it's like champagne. That's because the snowpack has been faceting over those 2 days, breaking those bonds, and all of a sudden snow that was wet, not so great to ski, is now very not cohesive, which is fantastic.
Is it for people who are fascinated in certificates, basically like the same process and the same versions?
Not exactly. I sort of lied a little bit that these two are disjoint processes and they don't happen at the same time. The way I would think about this is that rounding and sintering is always happening in the snowpack. However, sometimes that can be dominated by faceting. Because crystals always have, their entropy, temperature thing going on, but this is such a larger effect that doesn't matter that it's happening when this is happening, especially when this happens much faster. So then rounding and sintering, what does that do to the snowpack? More cohesive, that's the big one. bottom of the snowpack this happens, less cohesive, more cohesive problem. So when you're looking, you want to know where these are so you can know where the problem is, or where are your issues. And then wet snowpack melt freezes them. Self-explanatory. So again, snow crystals, things that fall out of the sky, things that stay around for a ridiculously long time and are our typical weak layer. Facets, surface ore, which is dangerous and forms by process of deposition, which is different from faceting, and melt freeze and grounds. That is the snowpack. And if you have any questions, please ask.
What's core? What's core?
Oh, corn. So corn is melt freeze. So it's continually going from the important thing is that it freezes. So it freezes, you know, it freezes over time. Exactly. Corn is I believe that specific video was Caltech. There's a different video that I showed is a Japanese lab. If you'd like the video, I'll either link it or provide some sort of link video download or whatever. I highly suspect that these are going to be done as well.
What would you search for? Snow leaving ice, snow metamorphosis?
University of Washington will give it to you.
Yeah. So there are ways to find the videos which we will provide, or at least I will provide.